Hello class, today we're starting chapter 10, which is all about circles. And so today we're going to talk about the basic parts of a circle, and we're also going to introduce circumference. So our objectives are to identify and use parts of circles and to solve problems involving the circumference of a circle. Alright, so let's talk about a circle. A circle is the locus or set of all points in a plane equidistant from a given point called the center. So circle is a bunch of points that are the same distance from a central point. And so we name it and we draw a circle and we put a dot in the middle. We put a dot in the middle so that it doesn't look like or get mistaken for a 0 or an O, and then we name it by its center point. Or we can write out circle C. A radius is a segment with endpoints at the center and on the circle. So it's going to have a point there, and then somewhere on the edge of the circle. So for example, we have a radius CE, and there are two more here. We have CF, and we also have CD. And don't forget to label them. They are like a segment, so draw the little bar above. A chord is a segment with endpoints on the circle. So a chord has endpoints. Both of them are on the circle. So for example, we have AB here. Its endpoints are on the circle. And we also have DE with endpoints on the circle. DE is a special type of chord, and it's going to be a diameter. It's a segment with endpoints on the circle that passes through the center. So if we look here, DE passes through that center point. And the other thing about a diameter is it's made up of two radii. So what that's saying is that I could have, if I'm given the diameter, if I cut it in half, we're given a radius. And if I have a radius and I double it, now it's become the diameter. All right, so identify each part on the circles below. So name, remember we name it by a circle with a dot, and then that center point. So circle P. And name a radius. I'm going to give you all the radii that are here. You only have to give one. So PN, don't forget the segment bar, PM, and PL. The diameter, there is only one diameter listed here. It's LN. It's the one that goes all the way across the circle. And then a chord. Remember, a chord's definition is it has endpoints on the circle. So MN, and then we always remember that LN, the diameter is always also a chord. Go ahead and do B on your own, and then we'll check that over. If QV equals 4, what is the diameter of circle Q? Well, QV, if we look at QV has endpoints on the center and on the circle, so it makes QV a radius. So if we times it by 2, we get our diameter. So we're going to take 4 times 2. And so we have a diameter of 8. There isn't a label given to us, so we don't have a label for our solution. All right, go ahead and try 3 on your own. It's kind of going the other way. All right, congruent circles. Congruent circles occur when the radii are congruent. And so since we know that GH is congruent to JK, then we know circle G is congruent to circle J. We also have concentric circles. Concentric circles are coplanar circles that have the same center. So if you look, we're actually going to name these circles both circle A. But we're going to have circle A with a radius of AB, and that's talking about our small circle. And then we're going to have circle A with a radius of AC. So same circle, centers, but they have different radii. All right, we have intersections of circles. We have 3 different types of intersections that can occur. If we look at our first one, they intersect in 2 points. Our middle ones intersect in 1 point. And our last one have no points of intersection. Now ask yourself, could I have 2 circles that are going to intersect in 3 points? What about 4 points? What about 10 points? So think about those and see if you can come up with an answer for tomorrow. All right, if the diameter of circle S is 30, The diameter is 30, the radius is 15, and the diameter of circle R is 20. So circle diameter is 20, radius is 10 then, and ds equals 9. Find CD. Okay, I like to draw these out in a bigger line so I can see them more. So we have R, and we have C, D, and S. All right, so circle S has a diameter of 30. We said the radius then is 15. And the radius goes from S to C. Then the diameter of circle R is 20. So from R to D, that one is going to be a radius of 10, because remember it's half. ds is 9 units. Find CD. So looking at the information we're given, we need to come up with what is x? What is that CD? Well, I've noticed that I have the 10 for my radius here, but I don't know any information here. So actually, I'm not even going to use that. I'm just going to look at this other side. So the whole thing is 15, and then part of it is 9, and so I need to find the extra. So we know x plus 9 is going to equal the 15. So what is x equal? Well, minus 9 on both sides, and we get x equals 6. All right, so our next problem is very similar. Go ahead and try that one on your own, and when you get there, you should be able to come up with an answer for that. All right, let's go ahead and talk about circumference. Circumference is actually the distance around the circle, and so we have some formulas. And so the circumference C of a circle equals the diameter times pi, or twice the radius times pi. Twice the radius is the same thing as the diameter, so diameter equals 2r. So we have d pi, and more often you're going to see 2 pi r. A lot of people are going to be familiar with that. Okay, so think about diameter is twice the radius, and do 6 and 7. If RT equals 10, find the circumference of V. Well, if we go ahead and look here, RT is our diameter. So that's great. We already have our diameter. So we're probably going to use the C equals D pi formula. And if we go ahead and do that, in our answer box it says exact or rounded, and so exact is going to have actually the number pi in our answer. So we're going to say 10 pi. That's the exact answer. Rounded is when we actually take the number 10 and we times it by the pi key on your calculator. So if you go ahead and do that, you're going to round to 1 decimal place. We'll decide. So if we do that, we get 31.4. This problem didn't come with labels, so we don't have any labels for our solutions. All right, the circumference of a circle with a radius of 2.5 centimeters. Go ahead and try that. Remember that D equals 2R. And here we go, another one. This one's got diameter of 16, so try that on your own. All right, and 11. An asteroid hit Earth and created a huge round crater. Scientists measured the distance around the crater as 78.5 miles. What was the diameter of the crater? So this time we're actually finding the diameter. And it says that we're given the distance around the crater. So distance around, that's actually our circumference. Okay, so they give us our circumference and we need to find the diameter. So if we are given the circumference and we need to find the diameter, we're going to use d pi for our formula. So let's plug in this 78.5 and set it equal to d pi. So we are going to take our calculators and divide 78.5 by pi. That's going to get d by itself. So our diameter ends up equaling, it says 24.987. So if I ask you to round this to the nearest tenth, this 8 tells that 9 to round up. So our diameter, we're just going to round to 25, and I'm going to put 0.0 because I know that it wasn't exactly 25. And this came in miles, so that's going to be my label. So we are given the circumference, and we are able to find our diameter. All right, number 12. A series of crop circles was discovered in Alberta, Canada on September 4th, 1999. The largest of three circles has a radius of 30 feet. Find its circumference. So we're given the radius, so you can use c equals 2 pi r, and I want you to find the circumference. All right, find the diameter and the radius of a circle to the nearest hundredth if the circumference of the circle is 64.5 or 65.4 feet. So, again, we are given our circumference and we want to find our diameter and radius. It's going to be easier to find the diameter first and then divide it by 2 to find pi. So, plug 65.4 in and go ahead and do this problem just like we did number 11. All right, last concept today is inscribed and circumscribed. Inscribed are polygons are inscribed in a circle if all of its vertices, those are the corners, lie on the circle. So inscribed, you want to think in. When we say something is inscribed, it means it's inside the circle. Inscribed is inside, or it could be inside the polygon. So if we look at our picture here, we can say polygon L, M, N, P is inscribed in circle, and remember we label circles by the center point. Then we have circumscribed. Circumscribed, circles are circumscribed about a polygon if it contains all of the vertices, corners of the polygon. So circumscribed, when we talk about circumscribed, we're talking about what is on the outside. And so polygons can be circumscribed around a circle too. So for this picture, we can say circle K is circumscribed about polygon, I'm just going to shorten polygon, L, M, N, P. All right. A square with sides length of 9 inches is inscribed in circle J. Find the exact circumference of circle J. Remember when it says exact, we want to be thinking that we're going to have pi in our answer. And so since it's a square, we know that this is going to be a 45, 45, 90 triangle. And so we need to find the diameter, which ends up being the hypotenuse for that triangle. And so we know that in 45, 45, 90 rules, if we're given the leg to find the hypotenuse, we just multiply it by the square root of 2. So our diameter is 9 square root of 2. And so our exact circumference then is going to be 9 square root of 2 times that pi. And then we have a label of inches. All right, so we have 2 more problems just like this. Find the exact circumference of K. I'm going to tell you that this here is a 45, 45, 90 triangle. So it's going to be similar to the last one we did, and except for this time we're not going to find the diameter. We're actually going to be finding the radius because those 2 legs are going to be the radius. So go ahead and find the leg, double it to get the diameter, and then do the circumference. And the last one, find the exact circumference of a circle with a circumscribed square with sides 10 feet long. So this means that the square is going to be on the outside and the circle is going to be on the inside. And it's got sides of 10. So you need to find the diameter. Let me draw in a diameter for you. So use that as a hint. All right, this video's gone long enough, so we'll stop there. You get those last few problems finished up.